We're now ready for problem 10 of these practice test problems. Now we're looking at ellipses. So here are two standard equations for ellipses. Once again, the key is A, if you look at these denominators, A is always larger than B. And if A is under the X, this is going to be a left or right ellipse. If A is underneath the Y, then that's an up or down ellipse. As these things go, in my opinion, ellipses are maybe the easiest object to work with. So I've written down the first problem, make sure I can share it. This is always tricky to get started. All right, let me try to share this again. All right, here we go. I actually started this problem a while ago, so you see some answers are here, but here's the basic problem. So let's go and work this out. So with these ellipses, the first thing you have to do is, first of all, like all these, you make sure your equation's in standard form. Now with the ellipses and hyperbolas, the key thing is you have to make sure one side of the equation equals 1. Right? If you look at all four of these equations for ellipses and hyperbolas, you've always got 1, the number 1, on one side of your equation. I guess the other thing to notice is there's no coefficients in front of any of these parentheses, but what you have is you can have, obviously you'll have numbers in the bottom of the fraction. So we look here, we've got a 1 over here. We've got our denominators here, nothing in front of the variables. So we're good to go. So this one, you notice 36 is bigger than 16 and it's underneath the X. So the standard equation, first of all, this is going to be a left or right ellipse, right? The standard equation for the left or right ellipse is x minus h squared over a squared plus y minus k quantity squared over b squared equals 1. So if we look at, these are going to be your vertices. Sometimes I call them major vertices, and then they call these the up and down, in this case the minor vertices, but in our book, they just call these two the vertices. And then the foci are always 2 points that are inside the vertices. And then, of course, you've got the center of the ellipse. So in this case, actually, they're asking for the 2 vertices, the 2 foci, and then to sketch the graph. So actually, what they want are the vertices, the foci, and then to sketch the graph. The center of an ellipse is HK. So let me just do a quick. So if you have a center of an ellipse, which is HK, say this is a left or right, A is the distance to each vertex. There are 2 vertex. That's why they call vertices. The plural of vertex is vertices. So there are 2 vertices. And then what I call the minor vertices, the distance B. So ready to figure out the vertex, you have to know the center. You have to know the value of A. The foci are in here, and the foci are a distance C. And in our formula sheet, that's why there's an equation that allows us to calculate the value of c for an ellipse. So it's c squared equals a squared minus b squared. So for an ellipse, the things we're working with are a and b. A is the distance from the center to the vertices. B is the distance from the center the other direction. HK are the center of the ellipse. C is the distance from the center to the foci. May seem like a lot of stuff, but as we begin to work through these, you'll see it's pretty straightforward. So if we want to find the vertices, the first step is to find the center. Now in our case, since there are no parentheses, H and K are 0. And once again, I'm going to, as we go along, sketch out what we're learning here, since the very last question is a sketch of the ellipse. Once you know the center, the keys are, you need to figure out A and B. Well, it's pretty straightforward, right? A squared is what's under x squared. A squared is 36, which means A is 6. B squared is what's underneath the y squared. B squared equals 16, which means B is 4. Once I know A and B, and I know the center, I can pretty much sketch the ellipse. So it's a left and right, and A is 6. So from the center, you move 6 to the right. Here's the center. Six to the left. So it's pretty obvious. This vertex is 6, 0. And this one's negative 6, 0. Now for the up and down, we move a distance b, which is 4. Now, I'm not always great at drawing these ellipses, but do the best I can. Something like that. So here are the two vertices. And they always ask for the smallest vertice first. So you look at this number. So it's going to be minus 6, 0, and then 6, 0. And then they ask for the foci. Well, the foci is the distance c. I don't know c, but with this equation, I know a squared and b squared. I can determine c squared, right? So c squared is a squared minus b squared. So if I want to find c, right, I have to take the square root of both sides to find c. Of course, now, even though this is a trig class, they expect you to remember how to simplify some of these square roots. If you don't remember that, remember 20 is the same thing as 4 times 5. The square root of 4 is 2, so a 2 comes out. I think what they're going to want in the answer is for c to be 2 square root of 5. So what you do is, actually I have to grab my calculators. I don't know. I wonder what 2 square root of 5 actually is. It's probably, well, I don't know. I'm going to find out. Approximately 4.5. This is what they want for the answer, but so I can graph it, it's approximately around 4.5. So the foci are going to be 1, 2, 3, maybe in here, and then over here. But the actual points, so this one, this distance here is c, which is 2 square root of 5. So really it's a negative 2 square root of 5, 0. and then a positive 2 square root of 5, 0. So here are the vertices. Here are the foci. Here's my graph. That's basically what they're asking for, I believe, in this problem. So let's go back, enter these numbers, and see if we've done it correctly. So actually, I already have the vertices in here. So the foci, I said the smaller value, the smaller x value is negative 2 square root of 5. So here I have to go into my little, what they call a palette, get the square root sign, put a 5 in there. Go outside the square root sign, put comma, 0. And then 2 square root of 5. Comma 0. And then I look at my graphs. First of all, it's a left or right. It's got to be one of these two. And you notice here they put the foci up and down. Of course, the foci are left and right. So it's got to be this one right here. Looks like I already checked it, but we'll check all these answers. And it looks like they're all correct. So the next one, I assume it's going to be the same kind of problem. And it is the equation of an ellipse. Number 11, they want to know the vertices, the foci, and the graph. So let me write down this equation and we'll start working it out. Y squared plus 25x squared equals 25. So here is really our first problem we've done, maybe, where they've given us an equation that is not in standard form. Remember, standard form for an ellipse means one side is always equal to 1, and you might have some denominators here. Right now, this side is equal to 25. So I need to actually do some algebra, do some math, and convert this so that this equation is in the standard form. So like I keep saying, the key thing is one side has to be 1. How can I make this side equal to 1? Divide it by 25. Of course, if I divide this side by 25, I have to divide the other side by 25. Now, hopefully you remember when you have two terms in the top and you're dividing by a number, you can actually break this up. So it becomes y squared over 25 plus 25x squared over 25, which is just going to be 1. Now I'm going to write this, although you normally wouldn't, but just to make it clear, normally if you have a 1 in the denominator, you don't write that 1. But for this kind of a problem, especially as we're learning these, it makes it easy to see what's going on. If I go and put the 1 there, equals 1. So now this equation is in standard form. And now I know what kind of ellipse I have. My larger denominator is underneath the y. So this is going to be an up or down ellipse when I'm all done. And if I compare, if I write the standard equation, y minus k squared over a squared plus x minus h squared over b squared equals 1. First thing I can do is figure out my center, which is hk. Since there are no parentheses here, hk must be 0, 0. So my center's at the origin. Let me do my graph over here. Now a squared is 25, which square root of both sides, a has to be 5. So now, since it's an up or down parabola, I move up 5. 5 from the center, there's a vertex. And then 5 down from the center, and there's a vertex. And actually, this is going to be 0, 5, 0, minus 5. And now, in this case, left or right is going to be b. Well, b squared is 1, which means b is 1. So left or right, from the center, I move a distance 1. So this ends up being a pretty skinny up or down ellipse. But they always want to know the foci. So once again, for ellipses, c squared equals a squared minus b squared. I know a squared and b squared. So c squared, a squared's 25, b squared's 1. Take the square root of both sides. C equals square root of 24, which once again, this can be simplified. 24 is 4 times 6. So a 2 comes out. 2 square root of 6. Now, if I want to figure out how to graph this, grab my calculator. 2 times the square root of 6. It's actually around like 4.9. So on my graph, I go 1, 2, 3. It's almost 5. So there's like a foci. 1, 2, and there's another foci. All right. So then the foci, once again, since the center's at the origin, in this case, the foci down at the bottom is going to be 0, -2 square root of 6. And the foci at the top is 0, 2 square root of 6. So here's the vertices. Here are the foci. The graph should look something like this. Let's go back. So vertices, the smaller y value. So 0, minus 5. The larger y value, 0, 5. The smaller y value for the foci, 0, -2 square root of 6, and then 0, 2 square root of 6. Now, which graph is correct? Well, it's an up or down, so it's got to be one of these two. The only difference is where the foci here, the foci is almost at 5. It looks like it's on top of the vertex. And here it's down here. I may have drawn actually I drew my picture wrong, because the foci are around 4.9 and the vertex is 5. So my picture's wrong. So this one's actually correct right here. Turns out that the foci and the vertex are almost right on top of each other. So my little graph I drew was not quite right. I'll show you that in a minute. Let's go ahead and see if we've got these correct. All right. So let me do this. Let me just show you real quick. My graph is sort of wrong. I was looking to graph 4.9 and I started at 3.9. So that's not correct. The foci is really up here almost on top of the vertex. That was my little mistake. Maybe some of you caught that when I was doing it. All right. Number 12. Looks like another equation and figuring out the standard things. This one's a little different. I think the first two, the center of the ellipse is made the origin. Looks like that's not going to be the case here. I just take a first glance at this problem. Then write down the equation for number 12. X minus 6 quantity squared over 49 plus y plus 7 squared over 36 equals 1. First thing, is this equation in the standard form? So I got a 1 here. I got my denominators, nothing in front of the parentheses. Yes, it's in standard form. So what kind of ellipse do I have? Well, since 49 is bigger than 36, looks like it's going to be a left or right ellipse. Now the center, which is HK. Now this is the same method I use like parabolas when I find the vertex. I know this is my H here, but you take the number including the sign, and then when I look at the center, I always do the opposite. So I got a minus 6 here. That means it's 6. Here I've got a plus 7. The opposite would be negative 7. So it's going to be 6, 1, 2, 3, 4, 5, 6, negative 7. So that's the center of my ellipse. It's going to be a left or right ellipse. A squared is underneath the x squared. A squared is 49, therefore A is 7. Once again, since this is a left or right, from the center, I move 7 to the left, 7 to the right. Now, instead of counting, if I'm here at 6, to move 7, puts me over here, and then 7, 8, 9, 10, 11, 12, 13. If I move 7 to the right, puts me here. These are both vertices. I move 7, that means it's 13, negative 7, and this is negative 1, negative 7. So there are the two vertices. Now to be able to graph the ellipse, I need the b to go up and down. Well, b squared is 36, which means b equals 6. So from here, I'm going to go up to right here, then I got to go down 6. So this ellipse almost sort of looks like a circle a little bit. My picture's not going to be too great because it is a left or right parabola, but it's hard to tell because this is just a rough sketch. Now the foci, a squared is 49 minus b squared, which is 36. So c is square root of 13, which does not simplify. Just so we can graph it, square root of 13 is like around 3.6. So what I do is I have to move 3.6 or square root of 13 from the center. So it's around 3.5. 1, 2, 3.5 maybe. Then 1, 2, 3.5 maybe. But the actual foci. Now this gets a little tricky because, of course, I know my value of y is just -7. The value of x, I'm sitting here at 6, and I have to subtract square root of 13 to get to this foci. So this is the x, and the y is just -7. The other foci, I'm here at 6, and the x, and I have to add square root of 13. My y is still -7. All right, foci always are a little messy. Let's see if these answers are correct. So the smaller x value of the vertex, -1, -7. And then the larger vertex is 13, -7. Now the foci, the smaller one is going to be 6 minus square root of 13. 6 minus square root of 13. And the value of y is -7. And then the larger foci is 6 plus square root of 13 -7. Now, as graphs go, here it's a little more clear because it's got to be one of these two, but you can see this one is a left or a right. So I'm pretty sure it's going to be this one right here. All right, I see all green checks. That's good. All right, different kind of problem. 13. They give you the graph. They ask you to find the equation. Now, when you find the equation for an ellipse, you actually need 3 things. You need the center of the ellipse, because that gives you HK. And then you need to know what a squared is and what b squared. Or you can say find a and b. Because once you find a and b, then you get a squared and b squared. So those are the 3 things we have to figure out. Once we know those 3 things, we can determine the equation. So this is definitely an up or down ellipse. Let me write down here everything we can figure out from looking at the graph, and then we'll go start working. So first of all, I think here the V and the V prime, they put those there to indicate vertices. So if I look at the tick marks and I'm very careful, it looks like in this graph, each tick mark is 1. So it looks like the vertices are 0, 7, and 0, -7. Although really, you know what the key is? I really want to know the distance A. A is the distance from the center to the vertex. So really, A is 7. The center, obviously, is at 0, 0. So the center is at the origin. So it means H and K are going to be 0, 0. And now I think this M here, they put it there for the minor vertices. And you can see from the center to this minor vertices 3. So that means B must be 3. And as it turns out, that should be all I need to figure out the equation. So here's the information we have. I know it was an up or down ellipse. The equation for an up or down ellipse is y minus k squared over a squared plus x minus h squared over b squared equals 1. H and k are 0. So that's just going to be y squared and then x squared. Now a, we know a is 7, so 7 squared is 49. b is 3, so b squared is 9. And that should be the equation of the ellipse. Y squared over 49 plus x squared over 9 equals 1. Like I said, in my opinion, ellipses may be the easiest of the 3 different objects we're working with. So y squared divided by 49 plus x squared divided by 9 equals 1. All right, that's nice. All right, here's another one. Number 14, so let's write down what we can pick up from the graph. And we'll go and figure out what the equation is. So once again, now this one looks like it's a left or a right ellipse. Now here, we're not necessarily given the center, but by giving us these 4 points, we can figure out the center. So in terms of x, if this vertex, if x is -8, and this vertex is 2, that means that's a distance of 10. So the center would be 5 from this vertex or 5 from this one. So if I go 5 from this one, I think I get to -3. So the center value of h is going to be -3. Now the k, or the up or down, up at the top I'm at 4, down here at -2, that's a difference of 6. So the center of those is going to be a difference of 3. So if I'm up here at 4 and I have to move down 3, I come down here. So it's like a k value of 1. So I'm saying the center is -3, 1, right there at the cursor, and that looks very much like the center. All right. So now A, we just talked about it. A looks like it's going to be 5 from the center to either vertex. So A looks like 5, and when you go up and down, B looks like 3, because the total distance is 6. Actually, A may not. Is A correct? Yeah, it went from 2 to -8, which is a total distance of 10. Half of that's 5. Yep. All right, I think I've got what we need. So now the standard equation of a left or right ellipse is x minus h squared over a squared plus y minus k quantity squared over b squared equals 1. And I think I have everything I need. So here we go. H is -3, x minus a -3, x plus 3 squared, a is 5 over 25. Y minus k, k looks like it's 1 squared over b squared, 3 squared, which is 9. That should be it. So x plus 3 quantity squared over 25 plus y minus 1 quantity squared over 9 equals 1. All right. So now, new kind of problem. Number 15, they give us some information and ask for the equation. So they tell us the two vertices, plus or minus 8 means it's like negative 8, 0, and 8, 0. And then they give us the foci, plus or minus 5, 0. So it's like negative 5, 0, and then 5, 0. So I'm going to do what I always do with these problems, and what I encourage you to do. I'm going to plot what I know, sketch a real quick graph, then hopefully become very clear what's going on. So vertices, negative 8, 0. 1, 2, 3, 4, 5, 8. And then 8, 0. So obviously, it's going to be a left or right parabola. Foci are minus 5, 0. And 5, 0. So really the key thing is, so I know now the center is going to be at the origin. Distance from the center to a foci is actually B. No, it's not, it's C. C is the distance from the center to the foci, which is going to be 5. From the center to the vertex, that's A. Looks like A is 8. Now, if I write down the standard equation for a left or right ellipse, it's this. And like I said, we need 3 things to find the equation of ellipse. We know we need to know the center, which we have. The center is actually, I didn't write it down. The center is at the origin. So we know H and K. We know A because we know the vertex. What we don't know is B. Turns out we know C, but we don't know B. However, there's a way to determine B, and that's because we know with the foci, we've got this equation. Now in this case, I know C, I know A. This gives me a way to figure out B. Matter of fact, B squared, if I rearrange these, if I add B squared to both sides, subtract C squared to both sides, B squared equals A squared minus C squared. So B squared, A is 8, we square it, 64. C is 5, we square it, it's 25. So that to me looks like it's going to be 25. Looks like B squared is 39. Now what's interesting is for an equation, I really want to know B squared. I don't really need to know B, so there's no reason to do anything else because I've got B squared. So I should have everything we need. So H, well, the center's at the origin. So H and K are 0, 0. So X squared over A squared. If A is 8, square it 64, plus Y squared over B squared, which is 39, equals 1. So let's see if this is correct. All right. x squared over 64 plus y squared over 39 equals 1. All right. So now here's another one. It's like the last problem for ellipses. Let me write down what they give us. Number 16, they say center at the origin. So the center, which is HK, is 0, 0. And then the vertices, plus or minus 0, 0 plus or minus 5. So it's going to be 0, negative 5, 0, 5. And then they give us a point. So 3, 2 is a point on the ellipse. So now they want us to get the equation for this ellipse. So let's just make a quick sketch. The vertices are 0, negative 5, and 5. So obviously, up or down ellipse, A is 5. I don't know B. I know the center. The equation for an up or down ellipse is going to be y minus k squared over a squared plus x minus h squared over b squared equals 1. So if I fill in what I know, since hk is 0, 0, a is 5, y squared over 25 plus x squared over b squared. So I need to figure out what b is equal to, and then I can add the equation. What I have to do is I have to use this point they've given me. This is a point on the ellipse, so I can take the equation of the ellipse and I can plug in 3 for x and 2 for y. So when I do that, so y is 2, so 2 squared is 4. 4 over 25 plus x is 3. 9 over b squared. What I really need to do now is here's an equation. The only thing I don't know is b squared. The rest are numbers. I can solve this equation for b squared, and then I'll have what I need to get my equation for the ellipse. Now it's some algebra. To solve for b squared, I'm going to subtract 4 over 25 from both sides. And in this one, I make 25 over 25. So by the time I finish all of that, I have 9 over b squared equals 21 over 25. Now, when they're old to math, you may or may not remember this or learned it, but when you have two fractions that are equal, you can cross multiply, which is a quick and easy way to sort of solve these. So 9 times 25 is actually 180, I think it's 225, equals 21b squared. So if I divide both sides by 21, I get b squared equals 225 over 21. And I think this might reduce, I think the top and the bottom, I can divide them by 3. So, I think it's 75 over 7. So let me, actually, I'm going to have to get a new sheet of paper. I've got too much work to do to have room. So what's going to happen is, so I know it's y squared over 25 plus x squared over b squared is 75 over 7. Now this right here is called a complex fraction, which I don't know for sure, but if you try to enter this answer here, they may count it wrong, even though it's not really wrong, but it's not in the proper form. They don't like you to leave complex fractions. So what you do is, the little trick when you have a fraction in the bottom of a fraction, you sort of flip it and then multiply it by the fraction itself. So when you do that, you end up with 7x squared over 75, if I didn't make any mistakes. Just for fun, I might enter this as a complex fraction. I'll just see if it likes that answer. I really don't know. It's not really a wrong answer, but it's just not the way math people like you to give the answer. So let's say y squared over 25. And just for fun, if I can, this is a little tricky to type in. So it's x squared 75. See if it likes this. All right. Equals 1. I don't know if it's going to take this or not. Normally you don't write it this way. Wow, it did like it. Okay, that's pretty generous. Actually, probably the way I would typically write it would be like I showed you. See if this one's okay too. Yep, that's nice. I'll take either answer. Okay, so that's all the ellipse problems. So now we have one more type of problem to do, hyperbolas. So let's stop this video now and we'll do hyperbolas on the next video.